Mulching and cover cropping. Zero and minimum tillage techniques with mulching greatly help to conserve soil, water, fertility and energy. However, these techniques do not completely arrest soil deterioration process ensured from continuous cropping. Soil compaction, acidification in some soils and nutrient losses by leaching, fixation in the soils and crop removal yet remain constraints for sustained crop productivity. Look at this picture. It shows how the soil productivity and nutrients are maintained under wild system and then under a crop production system. When we consider a wild system, which is undisturbed ecosystem such as forest or grassland, soil erosion or leaching of nutrients is minimum. The situation is totally different in a crop field. Continuous inputs of both organic matter and nutrients are essential to maintain high productivity levels under continuous cropping. At the same time, soil erosion, nutrient losses from the system is speedily happening. This fact has stimulated research into new aspects of cover cropping and, more importantly, tree and shrub based fertility recycling systems which provide both organic carbon and nutrients. What is a mulch? Mulch is a layer of crop residues placed on the soil surface. There are different types of mulches depending on the source and method of mulch procurement and application. The technological methods of mulch farming differ from the basis of whether mulch is brought in or produced in situ. Although a wide range of materials is used as mulch, the most practical and feasible material is the residue from the previously grown crop. This diagram shows you how different mulches are categorized. Basically, mulches can be categorized into brought-in type and then in-situ type. The brought-in type can be categorized the mulches from plant origin and mulches from animal origin. The mulches from plant origin, some examples are crop residues and industrial byproducts. The brought-in animal originated mulches are manures, composts. When it goes to in-situ mulching, it can be categorized into annual plant base and perennial plant base. The annual plant base can be again divided into two categories such as live and suppress. Cover crops, live mulch, lay farming are some examples for live mulches with using annual plants growing in situ. Sod seeding and sod planting could be taken as examples for suppressed mulches using annual plants growing in situ. When we go to perennial plants, that can be divided into again two, in situ, brought-in. Agroforestry and Tongia are systems which provides mulches using perennial plants in situ. Cut and carry mulch could be examples for brought-in perennial based mulches. What do you mean by sod seeding? Sod seeding is annual crop is seeded onto an untilled terminated forage land or forage stand. So in these two pictures you will understand the annual crops are seeded onto the terminated forage lands. This is a mechanical way of sod seeding. This is a manual way. What is G.A.S system? The G.A.S system is a system whereby villagers and sometimes forest plantation workers are given the right to cultivate agricultural crops during the early stages of forest plantation establishment. Cultivation is often allowed to continue until trees, shade crops due to canopy closure. Let's look at live and in situ mulch systems. The term in situ mulch refers to the residues of dead or chemically killed cover crops which are used on the same land on which they were grown. The live mulch system is a crop production technique in which food crops are planted directly in a low growing cover crop with minimum soil disturbance. Main advantages of live and in situ mulch systems are it smothers weeds and it can play an important role in soil conservation and maintenance of soil fertility. What are the beneficial effects of mulching? These effects for the learning purpose can be divided into three types. The first one is physical effects. Mulching minimizes raindrop impact, improve rainfall acceptance through enhancement of soil structure and reduce rain runoff and erosion. This picture shows when there is no any mulching materials on the soil, the raindrops come and splash the soil particles and loosening them leading to soil erosion. When the soil is protected with some dead leaves or some mulching materials, the process is totally different. That means the soil is get protected. Let's see now the impact of raindrops on bare soil surface. Look at this picture. You will see here there are three stages whereby these impacts of raindrops on bare soil surfaces happening. The first one is detaching small soil particles. Second one is carried away by runoff. These detached soil particles are carried away by runoff. And the third way of getting the impact is soil particles are deposited downslope when the runoff velocity decreases. The brown color of the water flowing on this waterway or this river is clear evidence of soil erosion. let's look at how this situation is reversed when there is a soil cover, or what we call as a mulch. This photograph shows the plant residue or cover protects the soil from raindrops and impact of splashes. This process tends to slow down the movement of surface runoff. More than that, it allows the excessive surface water to infiltrate satisfactorily and successfully onto the soil. This picture shows a naturally flowing stream where water is having its natural color. Witnessing there is no soil erosion is happening on upper stream. Now let's look at what are the biological effects which are impacting on the soil. Biological effects increase the activity and species diversity of soil flora and fauna, notably earthworms, increased biomass carbon and improved crop growth. Look at this picture. You will see here, when there is a mulch, the soil macrofauna are growing very comfortably and they are doing the biological kind of tillage in the soil and improving the soil structure as well as soil health. Now let's look at the chemical effects. Chemical effects alter nutrient status and influence crop growth. Now, let's look at what are the different forage legumes that can be used for in situ and live mulch farming. Leguminous cover crops. They are often used for in situ and live mulches because of their ability to fix atmospheric nitrogen when they are effectively modulated by rhizobia. The high forage value of these legumes may make them more attractive to farmers as part of their livestock could be fed as well as beneficial for the crop production system. This figure shows you how mulch is beneficial for a cultivation system. Look at the left side of this figure. You can clearly observe a mulch is on the soil surface of this agricultural field. The right side shows the bare soil is there on the agricultural field. When rain comes, when heavy rain comes, the water drops are getting onto the mulches and then get absorbed through these mulches and then ultimately infiltrated into the soil. But when there is a bare soil, the raindrops come with a kind of a speed and then they are splashing soil particles, ultimately leading soil erosion and removing of nutrients of the soil. Let's see the temperature amelioration power of the soil with having a kind of mulch. When solar radiation reaches the ground, when there is a soil mulch, the part of this solar radiation is reflected back and then part is absorbed to the soil. However, there is a kind of amelioration. Amelioration is happening with respect to the temperature in the cultivation soil with having a mulch. This ameliorated temperature is really beneficial for the soil organisms to grow, to populate as well as function comfortably in the growing media of the plant. But when there is a bare soil, whenever solar radiation comes, it gets absorbed into the soil and heat builds up. This situation is not suitable for plant roots as well as the soil fauna, macro and microfauna living. Therefore, the bare soil ultimately becomes less healthy when compared to the soil with kind of a mulch on it. When you are selecting a type of mulch, specifically live mulch, there are some attributes that you have to consider as a farmer. The live mulch should be easy to establish and have early horizontal growth vigor to cover the ground rapidly. It also should be weed competitive. It should produce adequate amounts, approximately 5 to 6 tons per hectare of litter. The live mulch should preferably be deep rooted, basically below the crop root zone is considered. The live mulch should also be perennials or else annuals which die out during drought to re-establish during the cropping season from the seeds. Let's look at some more attributes. Live mulch plants should fix nitrogen at levels required for other arable crops growing in the system. They also should withstand slashing or other cultural treatments as would be necessary for crop establishment and growth with minimal competition. They should not harbor pests and diseases which are affecting or attacking arable crops which are growing on the field. The live mulch should be shade tolerant to be able to withstand shading by crops. Live mulch should also produce sufficient seeds for re-establishment. Here are some examples for live mulch legume species. Pueraria physioloides and Centrosema pubescens, Arachis prostata. These three are propagated from cuttings. Other than that, Sopocarpus palustris, Macroptilium atripurpureum, Calapogonium muconoides and Mucuna utilis can also be used. These are some photographs of these live mulch legume species. This is Pueraria physioloides, which is having a purple color, very beautiful flower, which is characteristic. And this is Centrosema pubescens. This is also a vine species. This is Arachis prostata. This is Sopocarpus palustris. This is also a vine species. And this is Macrophyllum atropurpureum. This is also a vine species which is having a dark purple color flower, which is very easy to identify. This one is Calopogonium muconoides. So it is a bit different, having bit bigger leaves. This is Mucuna utilis. It is also a vine species. Now let's see the effect of land preparation and legume covers on weed growth. Land preparation and having a kind of legume covers on a cropping field is helping for controlling weeds. A primary aim of the live mulch concept is the replacement of a complexity of weeds by one fast growing and easily manageable live mulch. Look at this table. So weeds categorized as broad-leaved weeds and grass weeds are there on these two columns. Here the different land preparation practices and cover crops are also there. So when there is a conventional tillage, the broad-leaved weeds and then grass weeds are growing more in kilograms per hectare. And then when it is no-till, that means using herbicides, still some broad leaves but lesser number than the conventional tilling, and then grasses are growing. But when the cover crops are used, such as Aristide species, Centrosema species or Sophocarpus species, you will see here the lesser number of broad-leaved weeds are growing on the cropping field, as well as the grasses are more reduced under these three cover crops. So then you can understand, with the cover crops, grass weeds can be easily controlled when compared to broad-leaved weeds. The conservation tillage systems where the minimum tillage is practiced, the cover cropping is one of the elements, one of the principles, one of the practices. Cover crops are used as ground cover, mulches, green manure, nurse crops, smothering crops, and forage and foods for animals or humans. Cover crops can be annuals or perennial species, including certain legumes, grasses, and non-leguminous dicots. Characteristics important for cover crop selection include life cycle, seeding date and rate, winter hardiness, nitrogen fixation or scavenging ability, feed or forage value, and establishment costs of them. What are the benefits of cover crops? Erosion control. Cover crops can provide protection during the period when a primary crop is not present on the field. Plant residues reduce the impact of raindrops that otherwise would detach soil particles and make them prone to soil erosion. Surface runoff is slowed by the cover, allowing improved moisture infiltration. Not only does the above ground growth provide soil protection, but also the root system helps to establish the soil by infiltrating the profile and holding it in place. Cover crops and their decaying residues reduce pollution by preventing runoff of nutrients and pesticides into surface water. And by means of that, it contributes for reduced pollution. Cover crops may also allow earlier field access and improve traction during wet springs. Greater amount of organic matter and improved soil tilth is another benefit of cover cropping. Cover crops can add organic matter to the soil. Although increases in soil organic matter occur slowly over the time, including cover crops in the rotation can help to maintain or slightly increase soil organic matter. As organic matter and plant residues degrade, they produce compounds that cement soil compounds together into aggregates, resulting in improved structure and tilth. Aggregates in the soil contribute to greater soil permeability, aeration, water infiltration, and holding capacity, cation exchange capacity, and ease of crop emergence and root growth. Fixing of atmospheric nitrogen is one of benefits of growing cover crops. Legumes, in association with certain bacteria, have the ability to acquire the fixed nitrogen from the atmosphere. When high nitrogen legume residues remain in the field, they break down and release nitrogen and other nutrients which can then be used to subsequent crops. In general, most legume cover crops provide an equivalent of 50 to 200 pounds of fertilizer nitrogen per acre per year. Recycling or scavenging unused nutrients is another benefit of cover cropping. Certain cover crops tend to be very efficient at recycling or scavenging excess nutrients. When the cover crop dies or is removed as forage, some of the nitrogen will be released and reused by future crops or utilized as protein in the feed. Cover crops helps in increasing the beneficial organisms in the growing soils. Increased plant residues and the tillage practices generally associated with cover crop systems may improve the soil environment for certain beneficial organisms. Organisms such as earthworms, insects, and microorganisms can improve soil quality and increase nutrient availability by quickly decomposing organic matter and plant residues. Earthworms in particular help improve water infiltration and soil structure. Other insects that are attracted to the cover crops may provide benefits by preying on harmful pests or acting as beneficial insects. Partial weed control is another benefit of cover cropping. Cover crops partially control some weeds by competing with them for light, moisture, nutrients and space. Cover crops and their residues can act as mulches or physical barriers by smothering weeds, suppressing weed seed germination and growth, and lowering soil temperatures. Allelopathic compounds, which are released from living or decaying plant tissues, chemically interfere with weed growth. Cover crops are also possible feed sources for livestock as well as humans. Certain cover crops, especially grass species, can be used for livestock feeds. These crops can be grazed or mechanically harvested as haylage or hay. With proper management, grazing will have a similar effect because even though the tops are harvested or grazed, root mass and stubble remains to provide protection from erosion. Look at this picture. It shows clearly the different advantages of cover crops, enhancing soil structure such as improved aggregation, improved aeration, improved infiltration, and then increased soil organic matter, increased pH buffering, increased soil biota, increased nutrient cycling, and for the environmental quality through reduced nitrogen leaching, reduced erosion, reduced runoff. Cover crops helps. Cover crops also improve pest management practices by suppressing weeds, suppressing pathogens and suppressing nematodes.